Okay, let's take a look at number 1. We're trying to find the length BC. So we're looking for this length. What does it give us here? The altitude. So what formula are we going to use? Alt squared is equal to segment 1 times segment 2. What's the altitude?
6.
So 6 squared is equal to, what's segment 1? 7, and then what's segment 2? We can call it x, but I'm going to call it y since I called BC x, so just to call it something different. Yes?
Like the positioning of segment 1 and segment 2, you can put y in front for like segment 1.
Yeah, it doesn't matter which one's segment 1 and which one's segment 2. So we have 36 is equal to 7y, and then we divide by 7. So what do you guys get for this part that we're calling y? 5.1. So since y is 5.1, how do we find BC? We add 5.1 and 7. And what do we get? 12.1. So x is equal to 12.1. BC is 12.1. Okay, let's look at number 2. Find x. So what part of the big triangle is x here? It's the leg. So what formula are we going to use? Leg squared is equal to hypotenuse times the SOHL. So what's our leg? So we have x squared is equal to, what's our hypotenuse? 12. So remember, when we say hypotenuse, we're talking about the hypotenuse of the big triangle. And then what's our segment adjacent to, segment of the hypotenuse adjacent to the leg? 2. Remember, when we're talking about the SOHL, it's just the segment that's closest to the leg we're talking about. So 2. So we have x squared is equal to 24. We take the square root of both of those, so we get x is equal to 4.9-ish, right? You guys agree, disagree? 4.9. I don't know how you got that. On the test it'll say like leave in decimal or leave exact, but either way will work. So if you want to leave it as you had it 2 root 6, yeah, you can leave it as that. So number 3, write a similarity statement comparing the triangles. So where do we start when naming our triangles? So we start with the big hypotenuse and we can go to the little leg. So we can call our big triangle CBA, and that's going to be congruent to, now let's go to the medium-sized triangle. So we're going to start with the hypotenuse and go to the little leg. So CAD. And then looking at the little triangle, we start at the hypotenuse and go to the little leg, so ABD. So for this one, as long as you keep the same order for each triangle you're talking about. So I went from hypotenuse to little leg, but you can go from big leg to the little leg. It just, as long as everything is in the same order. So all 3 triangles have to follow the same consecutive order. Okay. So there's different answers for number 3. Okay, let's go to number 4. Find the geometric mean of 4 and 16. How do we find the geometric mean? So we take the square root of the 2 numbers multiplied. So instead of multiplying them, we can leave it unmultiplied and then just break it down from here. So what are the 2 factors of 4? 2 and 2. What are 2 factors of 16? 4 and 4. You could do 2 and 8 too. We'd get the same thing. But now that everything can be in a pair, we can just take those out. So we have a pair of 2's times a pair of 4's. So 2 times 4 gives us 8. So the geometric mean would be 8. Okay, number 5. Find x. So what part of the triangle is x here? The leg. So what formula are we going to use here? Leg squared is equal to hypotenuse times the SOHL. So what are we going to put for leg? X squared. What's our hypotenuse? 17. And what's our SOHL? 9. So remember, it's the segment that's closest to the leg we're talking about. So now we have x is equal to the square root of 17 times 9. So this you can simplify as a decimal, or it would just simplify to 3 square root 17. Did anyone find the decimal of this? 12.37. So either answer would work here. Any questions on this page? Alexis.
For number 4.
All right, next page. So for the big triangle, this is the hypotenuse, so we just add 9 and 8. So that's how we know the hypotenuse is 17. Yeah. Okay, so number 6, find AB. So let's label AB as our x. So if we're looking at this angle, angle B, so what is x in relation to this angle? Is it the hypotenuse, the opposite, adjacent? It's adjacent. What is 13? The hypotenuse. So which involves adjacent and hypotenuse? The cosine. So we are going to take the cosine of what? 34. We take the cosine of the angle is equal to adjacent over hypotenuse. So what did we say adjacent was? And what's our hypotenuse? 13. So we can multiply 13 on both sides in order to get x all by itself. So we have 13 times the cosine of 34 is equal to x. So we're going to put this into our calculator. So what did you guys get for x?
I got 10.66.
10.66. Does everyone agree?
I got 10.79. I got
10.78.
On the test, can we be able to round it up to 11?
I'll probably on the test ask for the nearest hundredth, but as long as you're close, because like here, one of you guys just rounded it in your calculator, so it's close enough, right? So I'll understand if you round it in your calculator or not. So it'll be specific on the test, like what to round it to, but I won't take off points if you're this close. As long as you show the work and you got to this step, then it was just a calculator mistake, so rounding in the calculator won't get you points off. Okay, ready for the next? Find AC. So now we're going to put an X where AC is. So looking at this angle, angle B, what is the relationship of angle or side X, AC? Is it, so it's the opposite. What is 13? The hypotenuse. So remember, the hypotenuse is always opposite of the right angle. So which one involves opposite and hypotenuse? Sine. So we're going to do the sine of what? Of 55, and that's going to be equal to x over 13. So we can multiply 13 on both sides. It cancels out on the right, so we get 13 times sine of 55 is equal to x. So we're going to put this into our calculator. 10.64. Close enough. So guys, for these two problems, one thing that you can look at here is, remember, the hypotenuse is always going to be the largest side. So if you get a number that's bigger than 13 in one of these, then you know you did your math wrong. Like say you got the leg as 15, your leg isn't going to be longer than the hypotenuse. So I would redo the math and see if you can get a different answer, because your leg is never going to be longer than the hypotenuse. Okay, number 8. Write sine of A as a fraction. So we're looking at angle A. We're just going to write sine of A. And what is sine? Opposite over hypotenuse. What's our opposite of angle A? And what's our hypotenuse? How do we simplify this fraction? 5 over 7. So we divide by 4 on the top and the bottom, and we get 5 over 7. So our fraction would be 5 over 7. We don't have to put anything in the calculator here. We're just writing the sine of A is equal to 5 over 7. So if it says write it as a fraction, you don't have to put it in your calculator. All you do is write the opposite over hypotenuse if it's asking for sine. So again, we're doing the same thing in number 9, but we're doing the cosine of B. So what is cosine? Adjacent over hypotenuse. So what's adjacent to angle B? 8 is adjacent, and what's our hypotenuse? 12. How do we simplify 8 over 12? 2 over 3. Perfect. Number 10, which angle has a tangent of 0.875? So here, we're doing the same thing from before, but instead of leaving it as a fraction, they just gave it to us as a decimal. So we need to find which angle they're talking about. It's either going to be tangent of A or tangent of angle B. So if we're looking at the tangent of angle A, what's tangent?
Opposite over adjacent.
Opposite over adjacent. So what's opposite of angle A? 16. And what's adjacent? 14. So now let's do the tangent of angle B. What's opposite of angle B? 14. And what's adjacent to angle B? 16. So if we put these two in our calculator, the first one we're going to get 1 point something. And then the second one we get what? 0.875, which is exactly what we're looking for. So angle B is the answer. Any questions on this page? Ready for the next page? Okay, number 11. Which angle has a sine of 3 over 4? So again, we need to do the same thing that we did before. We need to find what the sine of A is and the sine of C. So it's never going to be the hypotenuse angle, or the right angle. So it's never going to be the right angle. So it's either going to be A or C. So what is sine? Opposite over hypotenuse. So what is opposite of angle A? 22. And what is the hypotenuse? 24. If we simplify 22 over 24, what do we get? 11 over 12. So not quite what we're looking for. Now let's find the sine of angle C. What's the opposite of angle C? 18. And what's our hypotenuse? How do we simplify this one? 3 over 4. So our answer would be angle C. Okay, number 12. What is the measure of angle A? What do we have to do when it's asking for the measure of an angle?
Negative.
We do the inverse. So we do sine, cosine, or tangent of -1. So it's either going to be sine -1, cosine -1, or tan -1. We can use one of these three. Since it gives us all three of our side lengths, we can use any one we want. So which one do you want to use? Sine -1? Okay, let's do sine. So sine is what? Opposite over hypotenuse. So we're looking for the measure of angle A. So what is opposite of angle A? 15. And what is the hypotenuse? 17. So now in your calculator, you're going to do sine -1 of 15 over 17. What'd you guys get? 61.92 degrees. It'll tell you. So let's say we pick tangent instead. Remember, tangent is opposite over adjacent. So what's opposite of angle A? And what's adjacent to angle A? 8. So if we put tan -1 of 15 over 8 in our calculator, we'll get the same 61.92. So no matter which one you pick here, you could do sine, cosine, or tangent, you'll get the same answer. Yes?
What's a rounded?
It'll be specific on the test what to round it to. But if you wanted to round it to 62, that's an acceptable answer. Okay, let's go to 13. What is the measure of angle C? So what do we do when it's asking for the measure of an angle? The inverse. So which one do you guys want to do? Sine -1, cosine -1, tan? So let's do sine again. So what did we say sine is? Opposite over hypotenuse. What is opposite of angle C? And what is the hypotenuse? So if you do sine -1 in your calculator of 8 over 17, what do you get?
28.07.
So 28 degrees. Okay, any questions from this page? Ready for the last one? 14. What is the degree of elevation of angle A? So again, it's asking for the degree of angle A. So we have to find the measure of the angle. What do we need to do here? What do we have to do when we're finding the measure of an angle? The inverse. So we're going to use sine -1, cosine -1, or tan -1. But here it matters which one we pick because we don't have the hypotenuse. So which one of these three do not include the hypotenuse? Tangent. So since sine and cosine involve the hypotenuse, we can't use those. So we have to use tangent here. So what is tangent?
6 over 21.
Well, it's opposite over adjacent. What's opposite of angle A? 6. And what's adjacent? So we're just going to do tan -1 of 6 over 21 in our calculator. Yeah, you can simplify it, but if you're just going to put it straight in your calculator, you might as well just put it in your calculator. Avoid the risk of error, making a mistake. So what'd you guys get here?
15.94.
15?
0.94.
So 16 degrees.
Yeah.
Everyone agrees?
Yes.
Ready for 15? Okay, what is BC? So we're looking for side length BC here. So we can call this X. So how do we find X? What do we need to use here? Tangent. Perfect. Tangent of what?
51.
Of 51, because we're using angle A. And tangent is opposite over adjacent. So what's opposite of angle A? X. And what is adjacent? 13. So we can multiply 13 by both sides. So it cancels out on the right, and we get 13 times tan of 51 is equal to X. And we're just going to put this into our calculator. What do you guys get? 16? Sounds good. So BC is equal to 16. Everyone agrees?
Yes.
Ready for the last one? Okay. The pilot of a traffic helicopter sights an accident at an angle of depression of 18 degrees. The helicopter's altitude is 1,560 feet. What is the horizontal distance from the helicopter to the accident? Rounds the nearest foot. So we have the pilot of a traffic helicopter. So let's say he's down here. And he sights an accident at an angle of depression of 18 degrees. So if he's looking down, he needs to be looking down because it says the angle of depression of 18. So this is going to be 18 degrees. Oh, so the pilot is in the helicopter. So this is a helicopter. It's a helicopter. Right? That's not bad. I'm not an artist. The helicopter's altitude is 1,560. So in our triangle here, what's going to be 1,560? The height to the left. So this will be 1,560. And it is asking us for the horizontal distance. So this horizontal line we call X. So what can we do to find X? So if we're looking at this angle, it gives us the opposite and adjacent. So which one involves opposite and adjacent? TOA. So we're going to use the tangent of what? 18, and that's going to be equal to X over 1,560. We multiply both sides by 1,560. So we get X is equal to 1,560 times the tangent of 18. And we're going to put this into our calculator. And what do we get?
I have
500
Yeah.
feet. All right, so you're going to have a question on your test where you have to draw the triangle like this.